drugs. And now, as you will see in today's presentation that Dr. Teran will introduce when he introduces Jadon, how we're using deep learning in detecting certain cancers. But so appreciate you all coming. I just want to make a quick note that we are going to be augmenting this series. This Monday series, we are going to be having faculty, student, staff presentations. And shortly, I will be sending out a calendar of the presentations for the next several Mondays. So we will be having faculty and students from across the campus, across disciplines, who will be telling us about their work so that we can all get engaged and have discussions about it and hopefully help further advance that particular investigation. Remember, data science is all about data science and its tools, artificial intelligence, machine learning, deep learning, is all about augmenting and accelerating traditional methods of research. So, with that being said, I'm going to let Carlos Terán. Dr. Terán, would you please go ahead and introduce our speaker and give us a little bit of background?
Yes, so today we have an amazing guest speaker, which is Jadon Ferrance. He's a student CIS department in the computer science concentration. So Jadon have a quite good experience working with machine learning and deep learning techniques. He was in Rome using the broad study data science programs, where he was developing first working with biases in machine learning and deep learning models. And then lastly, he has been working with image analysis, and this is part of his work that he was actually working during this that started working on this last summer. And the title for this project and this presentation is Deep Learning Framework for Automated Lung Cancer Detections with Integrated Grad-CAM for Histopathological Images Explainability. So I will let Jadon to discuss about this topic in his presentation.
Alrighty. Good afternoon, everyone. My name is Jadon Ferrance, and my mentor was Carlos Danan. And today I'll be presenting my research on deep learning framework for automated lung cancer detection using histopathological images with integrated Grad-CAM to improve model interpretability and trust in clinical decision making. Lung cancer remains the leading cause of cancer-related deaths worldwide, with about 1.8 million deaths annually. The high mortality rate is largely due to the late-stage diagnosis. Symptoms often appear only after the cancer has already progressed, which reduces the chances of successful treatment. Chest x-rays, which are widely used, often fail to detect small or early stage tumors. This diagnostic delay leads to poor survival rates, and manual interpretation of medical images is the time-consuming and prone to human error, especially when dealing with large volumes of data. Histopathological images offer high-resolution, cross-sectional views of tissue and reveal cellular abnormalities that standard scans might miss. They've become vital in identifying early-stage tumors. However, interpreting these images requires a specialized expertise that can be very time-intensive. This is where deep learning, especially convolutional neural networks, also known as CNNs, plays a transformative role. CNNs can learn complex visual patterns, automatically detect cancerous nodules, access tissue texture and shape, and even estimate cancer stages with minimal human oversight. For the framework overview, our framework incorporates three advanced CNN architectures: ResNet 16, EfficientNet, DenseNet. Each model processes histopathological images to classify cancer types, to enhance transparency and clinical trust. We use Grad-CAM, which visually highlights which parts of the image influence each prediction. For ResNet 16, we use residual connections to solve the vanishing gradient problem in deep networks. By learning residual functions instead of direct mappings, ResNet is able to extract subtle features from medical images, which is essential for detecting early indicators of lung cancer. For the DenseNet is able to connect each layer to all other layers, promoting efficient feature reuse and stronger gradient flow. This architecture is particularly effective in analyzing fine gradient visual patterns in histopathological scans while using fewer parameters than traditional networks. For the EfficientNet, it uses compound scaling to balance network depth, width, and resolution, achieving high accuracy with minimal computational costs. This makes it well suited for clinical environments with limited resources or when processing what must happen in real time. Now, as far as explainability with GradCam, to address the black box nature of deep learning, we integrated the GradCam because it's used to generate visual heat maps that highlight the regions of the image that's basically most responsible for the model's prediction. So this basically enhances the trust among clinicals and confirms that the model is focusing on biologically relevant areas. For the data set, it was about 25,000 histopathological images across 5 classes, including benign lung tissue, adenocarcinoma, squamous cell carcinoma, and two colon tissue types. This provided a balanced data set to train the models to accurately differentiate lung cancer subtypes and basically be, in a sense, just make it so it's more refined so that there's less likely for any inaccurate data. As far as the data preparation, all the images were resized to a 244 by 244 pixels and then normalized on a 1 by 255 scale. We also split the training and the testing sets into an 80-20 ratio and used a batch size of 32 to ensure stable learning across the entire architecture and optimize the GPU usage during the training. We evaluated each model using accuracy, precision, recall, F1 score, and AUC. The framework achieved up to a 90% accuracy with low false positives and negatives. GradCam confirmed that models focused on the correct image regions, validating the framework's clinical reliability. Here's just another image of the GradCam. So the images on the far left are the actual images of the lung tissue, and then the colorful images are the GradCam highlighting the areas that are most effective towards cancer. So where it's blue, it's less likely. Where it's red, it's more likely that those tissues are infected with the cancerous cells. For clinical value, combing high accuracy deep learning models with visual explainability tools like GradCam has great potential in real world diagnostics. Our system can reduce radiologist workload, improve early cancer detection, and increase transparency in clinical AI adaptation. Now for the conclusion. To conclude, this study demonstrates how deep learning, especially CNN-based architectures, can be effectively used to detect lung cancer from histopathological images. Out of all the models we tested, VGG16 delivered the strongest overall performance. While more modern architectures like EfficientNet and DenseNet offer advantages in efficiency and depth, VGG16 stood out in classification and accuracy. Um, VGG16 achieved about a 97% classification accuracy and was highly consistent precision-wise and recall across all five classes. During its training, it's reached a validation accuracy of 96% and maintained a low validation loss of 0.098. These results suggest that despite being a more traditional architecture, VGG16 remains highly reliable for medical imaging tasks, especially when paired with interpretability tools like Grad-CAM. Moving forward, future work will focus on testing the framework in real clinical environments, expanding the data set to include more diverse cases, and developing lightweight models optimized for real-time diagnostic in lower resource communities, neighborhoods, and just settings in general. Thank you.
Okay, great. Thank you, Jadon. I appreciate your presentation. Very, very interesting. Very, very important. I have several questions, but before I raise my questions, I'd like to go to the uh, participants that we have here now. Um, how about any questions from our participants? The floor is open. Please just identify yourself and unmute yourself, identify yourself, and uh, we'll hear your question. Anyone? Well, Jaden, while people are thinking about their questions, let me ask a couple questions. What got you interested in this in the first place?
Well, my uncle passed away from lung cancer about 2 years ago, and it was mainly due to an issue where we caught it too late, and I just felt like it was it was something that was weighing on me and something that I knew I could make come to life. So I just decided to go full force with the topic.
And how long did it take you to? Well, of course, that's why so many of us get involved in several of these areas like you're doing. They're, a family issue, major societal issue.
Right.
Uh, what I'm very curious about is how long did it take you to learn enough tools to actually get in there and
Well, I've been working with Carlos for about 3 years now. Started in Rome, and ever since then, we've just always been working together, and he's been helping me expand my knowledge on AI in general and explainable models of the such. And we've been working together every semester, not on this specific task, but overall just different models that help me build the foundation to be able to do this now.
so you said you started in our program. The program in Rome that Jaden's talking about is something that we have going, sponsored by Microsoft. It's a course, a 5-week course called Data Science, Discovery, and Diversity, in which the students go through a tremendous 5-week experience. And I chuckle at that because that's a lot of learning in 5 weeks. Uh, Tell me, what did you get out of that 5 weeks that led you to this?
Well, actually, the project that I did then was on the conviction rates for marijuana based on certain communities and how over-policing affects why stats may show people of color using marijuana more than white people in certain communities. And I was able to use interpretable AI and data science work with one of my other fellow students, and we were able to make a model that was able to prove using numbers that it's due to over policing in certain communities, which causes the skew in data.
Wow. And you were able to do this in 5 weeks?
Yes, me and my fellow student Jadon Richburg.
Wonderful. Uh, so what I'm trying to get at is it's data science presents a tremendous opportunity to get more students who may not be interested in STEM to become interested in STEM because of the ability to do just what you did. 5 weeks, you're able to come up with learning the tools that you needed with some very, very interesting results. So I'm going to ask again, does anyone in any of the participants have questions?
I have a question. My name is Nelly Mateva. I'm a chemistry professor, and I'll be very happy to be part of this team. First of all, great work, Jadon and
Thank
Dr.
you.
Taran. Congratulations and a great presentation. I wonder how early can you predict using this method? How early on what is the earliest stage that you can predict by this method, and what is the accuracy of that?
So the accuracy that we got from the model was 96%, but keep in mind I only did the coding work for it. So to get true accuracy, we would have to put it in a clinical setting with people who actually understand lung cancer, doctors of such like that, because I basically what I did was create the model
Okay.
and trained it so it's able to do such, but to make sure that it's 100% accurate, we would have to present it to people who are educated in the cancer area of the actual work to make sure that everything that I did works out.
Okay. Well, so not only from this work, but in general, um, what can you predict the type of cancer?
So yes, let's see. So there was 5 stages that we had, and it started from benign to I forgot. Benign to
Well, I guess certain
right, but
pathologies.
it's not in the sense where it's stage one, stage two, stage three.
Oh,
It's just more where you can tell if the image of the tissue, there's cancerous cells in it, and if so, how far gone are the cells? So the darker the heat map is, like on the Grad-CAM images, shows the more far gone the cancerous cells are in the image of the tissue.
okay.
So what we would have to do was then we would have to take this data and go to an actual doctor and have them cross-check it to make sure that it's actually accurate.
Oh, yeah, this will be wonderful. This will be wonderful, yeah, indeed. Um, well, and where did you get the images from?
We used 25,000 images that we got off of a data set through Kaggle.
What is that?
It's just a data research website where people
Oh,
put like data that they've collected and stuff online for other people to use.
oh, I see. I see. So, what are you planning to do next? What comes next?
Well, what comes next is introducing it in actual clinical settings, so taking it to local clinics and basically taking it to more higher professionals like doctors and cancer researchers so that they're able to cross-check my work with their work and make sure that it's all accurate.
Okay.
Uh,
Thank you. Thank you very much. And it was wonderful. Thank you.
Thank you
Jay,
as well.
uh, extending on Dr. Mateva's questions, have you set up anything with one of these cancer centers at all to do this?
No, I have not. Me and Carlos actually finished this in the summer, and we're actually gonna be working on doing that next.
So let me suggest, and I'll get with Carlos on this. We have a partnership with the machine learning department at Moffitt Cancer Center.
Okay.
And I'd like to, and Carlos knows them, but I'd like to reintroduce Carlos and you to our contact there. We're actually involved in helping them develop their machine learning department. And this would be perfect for our partnership with them. This is very, very interesting work. And so I'll do that. But the other question I have is model that you've used here, you're using it for lung cancer. Is this transferable to say some other? Could you use it on some other cancers?
Um, I think I think it should be possible as it's really just an image of the tissues. So that would be something I would have to test, but I would think it is possible to be transferable amongst different types of cancer types, as long as it's able to be viewed on a tissue level.
Yes. Yeah, it's really about the tissue, right?
Right.
It's about the changes in color. This is what you're doing.
Jadon, my name's Elizabeth Mazzi. I'm in research at the College of Pharmacy, and that was great. I have some questions about your uncle. Now, when you said he was diagnosed late, did he have symptoms before?
Yes, he was coughing up blood. He had a lot of like respiratory infections before, and I think it was due to lack of resources why he didn't get checked when he should have. And that's also why I went with this topic because I feel like systems and applications like this can be implemented into lower income neighborhoods, and it can just the give people a way to be able to tech something early in them that would have costed them a whole bunch of money. And I just feel like this could help people nip it in the bud before it's too late.
Well, I have a question about that because this is invasive. By the time they take a tissue sample, it's now invasive. But I'm wondering if in like low income neighborhoods where they can develop a very cheap screening that's non-invasive. And I don't know, I mean, what they have for blood right now or blood analytes to detect lung cancer. But I think that would be, I mean, by this time they have to have a physician, right, to get a biopsy, correct?
Right,
And many people can't even afford that, right?
right,
So early detection, it would be great if there was like some kind of like breathalyzer or something where you can analyze some kind of, I don't know, a device, that people
right.
could just like, at the Dollar Tree you get, you can test or like a COVID test or something like that.
Yeah.
Uh, yeah, early detection is terrible. And so was your uncle also exposed to something in his lungs?
I'm not entirely sure. He did do a lot of construction work. That was his whole entire career.
Oh, that's it. Yeah.
So that's normally what they say leads to it as well.
It would
Um,
be great if you could also do data and analytics on construction worker and lung cancer, rates of lung cancer, because they work with so much of that toxic substance,
right. Yes.
concrete.
Yeah, and this may not be only for, both for Jadon and for Dr. Turan and for the other people who are involved in this, studying the causes, the root causes of lung cancer based on available data. Of course, this is always work in progress, but at least, we know some causes, but what in particular areas. So to we were talking about health disparities, and we should talk about this, but this may be also something which you may think to study based on social factors, economic factors, and so on. So think about this too.
And yeah, because prevention is really a large impact. If you
Yeah.
get into the prevention world, but you think about your uncle, he was exposed to like concrete dust, right? And wood dust and all that his whole life, right?
Right.
Did he wear a mask or?
I'm not entirely sure.
Yeah. When was that? Was it recently or maybe?
Yes, he passed away October 2 years ago.
Okay.
So how long did he work in the construction industry? And the reason why I'm asking that question is because a couple decades back, asbestos was the big worry in
Right.
reconstructing buildings and deconstructing buildings. Was he involved in that at all?
Yeah, my whole family grew up in New York, so they were part of all the like skyscraper buildings and stuff like that. He's been doing it for about 40 plus years.
Ooh.
Yeah.
Did,
Uh-huh.
did he work at 9/11?
I'm not entirely sure, but I know they did work around buildings in that area. They've done
Because
multiple airports.
because those trade towers were filled with asbestos.
Oh,
Right,
Yeah, that's it. That's not that long ago.
right.
That's not, oh,
This
you
is
know,
very interesting. Yeah.
yeah, I
There's
really,
a lot of people who worked at the 9/11. I think they ended up with lung cancer.
that's, yeah. And I was getting to that because, like you said, there was a lot of asbestos back then, a
Right.
lot. And this would be interesting that, if we had data from around those years there, just what the death rates were in the various diseases there with related to lung cancer. This is fascinating work, Jadon. Are you planning to continue on with this?
Yes, I'm planning on to continue on with this with Professor Tanan.
So what do you plan to do when you graduate?
Um, not entirely sure. I definitely want to stay in this field of work. Um, I truly feel like data science work is what relates to me the most because I'm the type of person to find a problem and try and find the answer. So I feel like that's exactly what data science work does as well. And yeah, I just hope to stay in this field doing this type of work as well.
Well, this is one of the outstanding, what we refer to as the emerging sciences and technologies. It's one of the emerging sciences and technologies, and it's at the cutting edge. And look at what you've started, and I would encourage you. This is a tremendous field to be into, working in the health sciences, working with people, medical doctors, researchers. What data science is about is augmenting and accelerating traditional methods of research. So just with the tools that you have, you can help the researchers that are at the bench accelerate their research. And that's what's going on here.
Right.
So I strongly encourage you. If you stay in this field, you'll have a beautiful future, let me tell you.
Thank you. I appreciate that.
Do we have questions from other people in the before anyone else?
Dr.
Carlos?
Allo, I have a question about because we're working with Mayo right now with Dr. Reams, and
Okay.
she has her histology slides for prostate cancer.
Oh wow, this would be great.
Yeah,
What?
and the thing is, though, and you can't really tell. It's a staining. She's staining for a protein, but I'm going to be extracting, actually, this would be great. I'm going to be extracting the RNA from the slides, or she's going to be, and then we're going to be using this new sequencing facility to do the transcriptome on, the expression profile. And it would be really interesting if we could collaborate in that area with her slides, She's,
Definitely.
So
yeah.
this is very, very interesting. One of my PhD students, well, when I was at Jackson State, one of my PhD students there actually worked on prostate cancer, worked with, I put him at the bench with Clement Yejun, who's now here in our biology department. And he came up with 44 genetic epidemiological factors impacting prostate cancer, also in breast cancer and myelogous leukemia. So I find this aspect would be very interesting, and I really want to put it to Carlos and John, Nellie, and Erdal. What do you think about the suggestion here?
Always for. Always for trying new things. And, sometimes you can find really exciting stuff about it. So, well, yeah,
So
absolutely.
what do you think? I'm suggesting, could we get a presentation um,
That would
from
be
your
great.
colleague?
Yeah, I'm just looking at her. She's it's under the Care 2 Center grant for this.
Oh, great. So she's with
Well,
our program.
yeah.
Yeah.
So, and they just got renewed. So I have to look at her project. But it is regarding prostate cancer diagnosis. And
This would be great. I really feel we all would like to hear that. So we've set this hour up on Mondays at 4 o'clock.
okay,
Can you find out from her and
sure.
when she's available? Because we can adjust our calendar, you know. But and just notify any one of us, Carlos, myself, Nellie, John, and
Okay, sounds great. Yeah. She can give an overview and any way we can help her. I'll do the sequencing. And the sequencing, of course, has bioinformatics. That's my area now. But
yeah. No,
the
this is beautiful.
yeah,
This is how we're
imaging would
going
be
to make
amazing.
advances by sharing each other's knowledge. That's what the purpose of this. So we're renaming this Monday series to be entitled "From Data to Discovery." I think it captures it better. From data to discovery. And so this would be exciting to see that. Can you let us know as soon as
Sure.
possible?
Yeah. So okay. So it's Mondays at 4 is pretty much going to be
Yes.
every Monday at 4.
Yes, pretty
That's
much. Yeah.
great.
Let us know. We're excited about this.
Okay, great. And yeah, that's great. We got a
And
lot of work to do.
yeah, this is the only way we're going to make advances by picking each other's brains. That's what we do in research seminars. Anyway, share our ideas. Okay. So, any other questions from anybody? I appreciate you all coming and just keep coming to our Monday series. We're going to have quite a variety of speakers from across the campus and from outside of campus, just like we've been talking right now. We're really looking forward to that. So if there are no further questions, I'll let you close off, Carlos.
Yeah, I just want to say thank you to you all for attending this seminar today and support our students on their research. Thank you, Jadon, for this amazing work that you have been working on and doing, your commitment as well, doing all the tasks to make this possible. And yes, as Dr. Olo says, so we are here every Monday at 4 p.m. and you are welcome to share your research with us.
Okay, thank you all.
Hey,
Thank you
take
so
Thank you.
much,
care.
everybody.
Thank you. Bye-bye.
Thank you. Nice evening, everyone. Thank you.
Thank you.
Thank you. Thank you for everything, Professor Tanan.
Thank you, Jadon, for your time.
Yes, sir.
This amazing presentation as always.
Thank you. I appreciate it. Hope you have a good one.
Thank you too.